Hi students, let's continue with the minimizing the literals, the number of literals in the Boolean function, that is algebraic, by using the algebraic manipulations. So in the previous video I had explained some of the examples how to minimize the literals in the Boolean function. So in this video I want to give some more examples so that at the end of the session you will get a complete clarity on how to minimize the expressions by applying the formulas, and you will get it by hearted the formulas also. Okay, so let's take an example: xy plus x dash z plus yz. So here I am using three AND gates. Three AND gates I am using and one NOT gate and OR gate I am using. Try to reduce this expression. How can I reduce? So simple thing. xy plus x dash z plus I am taking yz into x plus x dash, because I didn't get any common factor to do the operation. So let me reduce the equation like add the x plus x dash. Anyhow we know that x plus x dash is equal to 1 only. Y plus y dash is equal to 1 and x into x dash is equal to 0. So this is also another formula. X into x dash is 0. So instead of x plus x dash, anyhow y z into 1 is nothing but x plus x dash. Now xy plus x dash z plus xyz plus x dash yz. So this is what I get. Now what I am doing here is I am just taking xy as a common. Whenever I take xy as a common, this becomes 1 and here it becomes z plus, and here what I am doing is x dash z I am taking it as a common. If I take x dash z, here I am getting 1 plus y. So according to idempotent theorem, okay, according to idempotent theorem, let me write this. According to idempotent theorem, x plus x is equal to x plus 1 is equal to 1. In the same way, okay, when x dot x is equal to x dot 0 is equal to 0. So this is another formula. If x into x dash is equal to, you will get 0. It's a complement. Okay, no complement, you will get a 0. But x into x, if two x's or two y's are there, you have to take only one x. Suppose if x dot into 0 means anyhow it is 0 only. But x plus 1 is 1. X plus x is also x. X plus x is x. X into x is also x. So what I need to be apply here? 1 plus z is nothing but 1. 1 plus y is nothing but 1 according to the idempotent theorem. So I'll get xy plus x dash z. So how many AND gates I am using here? Only 2 AND gates, but here I am using 3 AND gates. So let me take one more example. Students, don't get confused. It's a very easy to minimize the literals. So try to multiply the thing first. X into x plus xy dash plus xy plus y dash. Now we know that x into x means what? According to idempotent theorem, x into x is nothing but only x. Xy dash, x into y, we don't get anything, no formula. And y into y dash, y into y dash or x into x dash, anything, it is a 0 only. Now let's take x as a common here. If I take x as a common, I am getting 1 plus y dash plus y. So try to apply the formula. Anyhow 1 plus y is nothing but 1 only. 1 plus y dash is also 1 only. So if I apply 1 plus y is 1 and y dash. Anyhow 1 plus y dash is also 1 only. 1 only. So then you are getting simply x as an answer. So these expression I minimize it to single literal. The x plus y into x plus y dash is nothing but x. So let me take some more examples. So I think you get an idea, students. So try to work out with more examples so that it will be very easy for you when it is given in the examinations also. So let me take another expression: x plus x y dash plus x dash y. So try to reduce here. It seems to be x. I can take it as a common. Whenever I take it as a common, 1 plus y dash, and here it is anyhow x dash y. So 1 plus y dash, it's nothing but 1 only. So that means x plus x dash y. So x plus x dash y, can I do anything? I can apply the De Morgan's law, right or wrong? So can you apply the De Morgan's the law? It's a theorem. Sorry, not De Morgan. It's a distributive property. So apply the distributive property. I'm sorry. You just apply the distributive property. So distributive property, if I apply x plus x dash into x plus y. Anyhow, x plus x dash or y plus y dash, what you'll get? 1. So 1 into x plus y. Anyhow, finally, this is your answer. W dash xy z dash plus xy z dash plus xy dash z dash plus xy dash z. So try to reduce the number of literals here. Take xy z dash as a common here. If I take it as, I'll get it as w dash plus 1. And in this expression, anyhow, if I take x y dash, okay, so x y dash as a common, so don't take it, let me write x y dash z dash plus x y dash z. So whenever w dash plus 1, it's nothing but 1 only. Okay, w dash plus 1, you'll get only 1. So x y z dash plus x y dash z dash plus x y dash z. So here I'm just taking x z dash as a common. Whenever I take x z dash as a common, I'll get y here. Okay, and here y dash. Okay, so x z dash as a common, y dash, and this is anyhow x y dash z only. Okay, y plus y dash is what? Y plus y dash is nothing but a 1. So you'll get x z dash plus x y dash z. So in this I can take z as a x as a common. Yes, you can take x as a common. You will get z dash plus y dash z. So how it look? Just apply the distributive property. So when I apply the distributive property here inside, I'll get z dash plus y dash is 1 and z dash plus z. Anyhow, z dash plus z is nothing but a 1. So the final expression you will get it as x into z dash plus y dash. If you want, you can multiply also x z dash plus x y dash. So this is your final minimized expression. This is what your expression is. So in this expression I used 1, 2, 3, 4 AND gates I had used. But here in this expression I used only 2 AND gates. Both are the equal expressions only. But here I tried to minimize the equation. So let me take one more example. So this is xy plus xy dash x dash z dash whole dash. So this is my equation. Try to minimize this equation by applying the formulas. So how can I do? Just take xy dash into, it's nothing but x double dash z double dash. Anyhow, x double dash means x only, z double dash means z only. Xy plus xy dash, x dash y dash whole dash means x double dash plus z double dash. That is a formula. Z whole dash means x dash plus z dash. So x plus z. Multiply it, xy plus xy dash x plus xy dash z. So next I'm just taking xy plus xy dash as a common. I'll get x plus z is one expression. I can't do this. Xy dash. Okay, x into x is nothing but x. So I just take only one x. Now this expression becomes xy dash. If I take it as a common, I'll get here 1 and 1 plus z. Anyhow, 1 plus z is nothing but 1 only. You'll get xy plus xy dash. xy plus xy dash. So this expression, if I apply the formula, if I apply the formula, I'll get final equation as x into 1 is equal to x. So this is the how the equation is reduced. This is your complete the Boolean expression. So this Boolean expression is minimized by using the algebraic manipulations. Here get only one variable x. Clear? Thank you.